Okay. Let's change the time here. Let me adjust my time. It's going to be in scripts. Change this to 80. Yeah. All right. Hold on. Something is not right. I can't see my. Oh, okay. That's good. Oh, welcome back. How good it is to be here once again. I think I'll wait a little. Like, let me wait 2 minutes before I start the stream. Before then, I should just be looking around to see if there is anybody in the stream. Nobody in the stream. One, four people. Okay. Let's wait a little more before we start. I just refresh the screen. One more minute. I'm so hungry. Okay, so let's get started. Yesterday, I went over a couple of questions, which is the intersection of arrays. So you can have a look at the video from yesterday to see the explanation on that topic. So I also solved this as well. There were 3 methods to solve these particular questions, but I think I showed 2, which is I showed all 3. So we use binary search, the intersection built-in function, and also hold on, let me see my summations. So here is I think this solution here is for so this is the binary search solution. This one is what? Oh, so this is binary search. This is the first one. The other one is so this is for finding frequencies, right? Finding the frequency and then removing the item from the array. So we'll solve this question also, which is kind of related, but there is a trick to this question. Now, instead of having, you see, in this array, in this other problem here, we had 2 arrays we were looking at, right? But in this case, in this question, we don't know the amount of arrays we are trying to look at. It's still looking for intersection between all the arrays in the given input, right? But this time around, the question is different. They are all similar, right? They are very similar, but instead of having 2 arrays, we have an unknown amount of iterables. In this case, they call it words, but you know what? Let's read the question and understand it first. So, given a string array words, right? Return an array of all characters that show up in all strings within the words, including duplicates. You may return the answer in any order, right? Now, here is our input, and then we have an output here, right? So we want to return every word that show up in every letter that show up in all the words in the given input, right? Or in this words array here, including the duplicates. Now, if you remember very well, this question is similar to intersection of arrays 2 and then intersection of arrays 1, right? Let's forget about intersection arrays 1, but let's look at intersection of arrays 2. Now the trick here is we want to return again. If we are returning every word that show up in all the words, right, every letter that show up in all the words, it means we are typically looking for the intersection, right? Intersection is simply something that appears in, in a given set of data, right? Let's say in an array here, the intersection is every word that appear in one of the arrays and in the second one, right? So in this case, we had 2 and 2, which is 2 and 2 also here. So the intersection will be 2 and 2, right? So now, but this time around, things are a bit different. Instead of us comparing 2 arrays, because in this case we know we have 2 arrays, so we can just do it straight away. This time around, we have, an unknown amount of I'll call this iterable, because we can iterate through strings, through every character in a string, as well as through every item in an array. So this is why they are very similar. So this time around, we are going to use the same technique for finding every duplicate, but the way we do this is to find the frequency of every item in each array, or in each word, right? I'm saying array, that's a mistake. So we'll take the first word, right? We'll find the frequency of every item. Now frequency is simply a dictionary of containing the letters, right, and how many times the letters appear in that array, or in this word. I keep saying array, in this word, right? And then we'll do the same thing, compare with the first word we had, right, and extract every value or every repeated letter, right? And then we'll do the same thing for the last word as well. Now remember very well, in this question, even though we saw the same items repeated in the second array, we only looked for the intersection, right? Intersection meaning we want the minimum frequency of a particular item that is common to both arrays. So in this case too, it will be the same. We want the minimum frequency of a particular letter that is common to both or every word in the array. If there is a letter that appears in one word and doesn't appear in another word, it means it is not an occurrence in the entire word. So that particular word will be removed from our frequency, right? Our frequency counter. And then we'll, extract everything out. So let me just show you what I meant by that. I'll copy these words here and I'll use this as an example. So let me go to the board. Okay, so I have some questions. Say, hey bro, hello, her best friend. Sanjay says, do you have any reference from any web extension algorithm? I'm not sure I understand that question, but please, if you can, explain more what you're trying to ask. Anyways, let's get back to it. I'll answer all questions at the end of the stream or at the end of the explanation. So let me not get so I will attend to everybody. So let's go back. So here is our word, an array of words. So let me break this back here. Okay, so like I said, we would need to know the frequency of every character in the array, right? We need to know the of every word in the words array. I don't know why I keep using arrays, but anyways, the reason why we need to do this is to know what is common to every other word in the entire words array, right? So I'll copy. So I've pasted that here. So first of all, we'll create a dictionary for each of these words, right? So let's do that. I'll use a different color. I'll say W1 for the first word, which is Bella, right? So Bella would look like this. If we mapped it out and find the frequency of every item, B will appear once, E appeared once, L appeared twice, and A appeared once, right? So that's for W1. W2 would be L appeared twice because we have one L here, another L. A is how many times? Once. B is once as well. E is once as well. Okay. So W3 for the third word. I'll just put W3 right here. This will be R appeared twice. O appeared once. We have two L's here. So L is 2 and E is 1. Okay, so this is the map of every word in the array. Now, we will do this programmatically, but I'm just trying to show you what we would do after the explanation. So here is how everything works under the hood. We'll map out every word, right? And we'll begin to track the frequency, the minimum frequency of a particular character in every word, right? So I'll say let's have the first word, right? We'll use the first word and compare it with every other word that we just mapped out, right? And then find out the minimum frequency of a particular word in the entire words list. So we take B for example, right? Now we'll look at the second W2 and find if B is there, right? So and then we'll find the minimum frequency of B in both arrays or in both maps, right? This is a map, this is also a map. So we'll find the minimum frequency and we'll return that minimum frequency. So now I'll put here a third map that keeps track of every character they have in common and the minimum frequency as well, right? So we have for the first character in W1, it's B, right? So we have B here. We also have B here, right? So but we don't have B in W3, so we don't add B. I'll call this our tracker, right? I'll call this track, right? Track map, or let's call this TM, right? Which is the tracking of every character. Wait, let me first of all remove this. So we don't have B, so we don't add B to our TM, right? So there is B here, there is also B here, right? They both appear once in both maps, right? Or in both word maps, but we don't have B here, so we don't add it to the tracking map list, right? Or the tracking map dictionary. So we look at the next character. Here we have E appeared once here, right? E also appeared here once, and there is also E here, right? So we can then add E to this tracking map here. We'll put E equal to 1. Now the next character is L, right? L, we want to look for L in all the word map. So we have L2 here, L is 1, L is also 2 here, and we also have L here, which is also 2. So again, that is valid. So we add to our tracking map here, L appeared twice. Then we look for the next word, which is A. Is there A here? There's A here, but then there is no A here. So our final results will look like this, right? Will look like this. We have E, 1 E, and then 2 else, right? So since we are going to return this as a map, we can just iterate and multiply you know, how many items appear in the tracker, right? So here's our tracker. We'll say, okay, so we'll do this. We'll say so the results will look like this. We'll have an array of 2L's, right? So we'll put 2L's here, L and then L, and you know the last item, which is a E, which is an E. So we'll add E. So here is our final result. Here is what we'll return at the end of the day, right? And let's take a look at the answer here, the output, the expected output in the question. Find common characters. Yes, so the expected output has 1 E, 2 L's, right? Which is what we did here. So how do we code this? Now we understand what needs to happen, right? But we need to also know how we can code this out to properly, you know, give LeetCode the results they want from us, right? So let's see. I will open my code editor now. Okay, so somebody asked the question, how about counting only for alphabets which occurred in the first word and keep a record of them? Yes, that's what we are going to do, you know, in code, right? But I'm just using this form to explain what's going to happen under the hood, right? So I've already solved this question, right? You can see here, where is this? Yeah, so this is the question. I've already solved it, right? But I still need to explain the solution, which is why I did that. Hopefully that did not sound too complicated. All right, so let's go ahead and bring this up. I'll remove this from here now, and I'm sure I've already solved this question, but I'll do it in the playground again, right? So for us to understand the different steps taken. I think it's in arrays. It's what 1002. Yeah, so I've already solved it before. So here's what happens, right? We'll take the first. Let me copy this. Now, what will happen here is going to be a bit different from what I explained. Now, instead of us creating, you know, a tracking map dictionary, we can use the first word as our tracking map dictionary, and you know, simultaneously remove every word we don't find in other word maps, right? So we don't need to create a new map like this, although this is what will happen ideally, you know, when you're trying to understand the question. But what we can do instead of creating a tracking map like this, if you want, you can do it this way. But instead of creating a tracking map like this, you can simply modify one map in place, right? So we can simply take this map here, right, and look for, let's say, B, right? If B doesn't appear in any of the other words, right, we'll then remove B, right? We'll simply set the value of B to 0, right? And we'll look for the next word, which is an E. So we have one E here, another E here as well, right? And then there is also E here. So we keep E as 1 here in the count, right? So again, we'll do the same thing for every other word that we don't find, right? So in this case, A here will become 0 because A is here, but then we don't have A in this third word list here. So we remove A by setting its frequency back to 0. Then we can just use this dictionary straight away to find, to return the occurrence of every character, right? So I hope that answered your question, Sanjay. Yeah. Sorry if I'm not pronouncing your name very well. Okay, so let's go ahead and where's my code editor? Hold on. Okay, so here it is. First of all, we need to, so we have a list of words, right? we want to, return the frequency of every word first of all, right? So what we need to do is we need to use this counter module, right? We need to use this counter module to find to quickly count every value in the word, right? In the word string. So otherwise, you can use you can use a dictionary and then count the frequency of every word, which I think just adds a little bit of step into your code, but that's still possible, right? You know what? Let me show you how that is done. First of all, let me explain what the counter does, right? Let's see the counter in action. So we'll first of all, okay, let me create, let's say this is word. I'll copy this word array here. Let's just use this. And I'll take the first word and try to count every value in it. So here's how we'll do it. We'll say so let's use the first word. I'll say, okay, so for character in words, I'll use the first word, right? So we want I'll call this counter, or I'll say character count, right, is going to be equal to a dictionary. So character count for a word in the words in this first word here, which is Bella, is going to be equal to, so we'll need so character count, first of all we will need to know if the character exists in the map first of all. So say if character in character count, right, then we want to set character count of that character, right, plus equal 1, right? Otherwise else we can just say character count of that particular character to be equal to 1, right? And at the end of the day, we can print out character count to see what goes on. Character count here. So let's run this and see. Now you can see we have B1, E1, L2, and then A1, right? So that's how that's another way we can count every character in a string. But the problem here is that you can see this is just a lot of, I mean, it's not too much, but like it takes about 9 lines of code to do all of this. No, 7 lines of code, yes, to do all of this. But using the counter module, right, things are a bit faster, right? So here is what the counter module does. We can say I can just put character count 2 equals to the counter, right? So let's import the counter module here. Import this name. So import this from collections. Yeah, so we have counter here. So now we have the counter module. All we need to do is to pass it the word, right? Words at 0. I'll just put it like this, and let's print counter 2, print count character count 2. Yes. So let's see. You can see we still have the same thing, right? In this case, it's even sorted in I think in order, but I'm not really sure about that. I haven't explored the counter module that much or that well to know what exactly how exactly the result is arranged. But you can see we are still counting the frequency of every character in the array, which is good, right? And it takes us less code to do that. So which is why we are going to make use of the counter module to count every value. And you can still do this, right? You can say character at L. Sorry, we can get the character at L, right? You can see the value of L is equal to 2, which is also the same thing here. So let's go ahead and back to our question, right? So we can, I'll just bring back I'll copy the other part of the question. So let's copy this part. Right. I'll copy this and paste it here. So we need the list, import this name. Yep, we haven't used counter, which is why it is, grayed out. So we need to first count. So I'll call this. Now my tracker is not going to be an empty dictionary. I'll use the first word as my tracker, right? And eliminate any word that is not part of it, right? That is not that does not appear in other words, right? So tracker is going to be equal to counter of the first word. This microphone is blocking my view. So counter of the first word. So the first word is going to be words at index 0, right? Now we can then iterate through the array and find every other word, right, to eliminate the ones that don't repeat in this in every other word. So we'll create a map. So here we'll have b equal to 1. So if we are looking at b for the first time and b does not appear in this label, or so label has b, so but roller does not have b, so we need to remove b from our tracker, right? And by removing b, we'll simply set the frequency of b back to 0. So it will then be removed from the tracker dictionary. So here's what we need to do. So we iterate through the array for every other word in the words array. So we'll say for I'll just use I, since we need the index, right, to create the words. So for I, or we can even use for word, right, for word in the array, but I prefer using the index this time around. So I'll say and the reason why I'm going to use the index is because we want to get every other value except every other word except the first one, right? Because we've already taken the first one here as our tracker, so we don't need to repeat it. So we'll say for I in range. So we start from 1, index 1, all the way to the length of the words, right? Then we'll say so we'll create a current count, right, equals to the counter of the current word in the iteration. So that will be word at index 1, or more dynamically word at index I. So words at index I, like this. So this will simply replace it will take the second word, since we've looked at this and we are starting from index 1. So I will be equal to 1, which means the second word in the words array. So, and then what we need to do now is the elimination if a particular word does not appear in the first tracker, right? And also we need to take we need to find the minimum frequency between the both dictionaries, the current count and the tracker count, right? So let me show you what I meant by that. So we'll say for character in the tracker, right? In the tracker, right? Now, if a character does not appear in the tracker, right, we'll remove it. Else, we'll find the minimum frequency of that character, right? So we can say so for every character in the tracker, right, if character is in the current count, right, we want to find the minimum frequency of for that character, and we'll set the minimum frequency's value back to the tracker, right? So let me show you what I mean by that. So if we found B here, right, and let's say we also have B here, but this B here is 2, right? But this time around, oh sorry, let me use another word that is common to all of them. So this is going to be, okay, we can still use this. Let's say we have B, or yeah, we have B here and we also have B here, but B here is 1, right? They cannot have two B's in common. They can only have one B in common. So we need to find the minimum frequency of B in both dictionaries, right? By simply using the minimum built-in function. So here's how we'll do. So if the current character we are looking at, which is B, if B is also in current count, then we need to set the minimum frequency of B back into the tracker, right? The minimum frequency of B between these two, right? So the minimum value of B here, if I set this B to 2, would be 1, right? So we would need to keep the value of B in this tracker. Now this W1 is our tracker, so we are not using W1 again, we are using the tracker instead. So otherwise we would have created this this tracker dictionary and then add values into it, which I think is possible, but it just adds a little bit of step into our code. So we'll need to do this instead. So let's take, if the character appears in this, right, we'll say tracking or tracker at this character, right, the value of this, the frequency of that character is going to be the minimum between current count at the character, right, and tracker at this character here. So what this does is, if we take a character at, let's say W, right, if we do this, where's my pen? If we say W1 at B, right, this will return 1, right? The value of this will be 1. Let me put an arrow. This will return 1. If we say W2 at B here, right, sorry, at B like this, this will also return 2, but then we'll find the minimum by passing in this both values like this, right? So the minimum will simply be mean between 1 and 2, and we know the minimum between 1 and 2 is 1, right? So we can then get the minimum that way. So let's do that. So yeah, we've already found the minimum here. Now if the character is in current count, we'll set the tracker, the frequency of that character to the minimum between the current count, the frequency of that character in current count and that in the tracker. Otherwise, so we'll say else, right, else the tracker, right, at that character has to be removed, right? So character is going to be equal to 0, right? So meaning we've removed the character from the tracker, right? So let's say in this case we found, let me go back, let me erase oh sure, sorry, I didn't even click on this page. So let me remove every other thing here. I will demonstrate that quickly. So let's say in our first iteration, right, we created this dictionary. So I'll move this dictionary here, right? I'll move this here. This will be in the second iteration. So in our first iteration, we created this dictionary, So let's move this here. Let's move this here. Oh, come on. Okay, so we will make the comparison between these two, right? So we have a B here and another B in this dictionary here. So we look at both B's, right? Now there is a B here and there is a B here. So even if we find the minimum between 1 and 1, we'll still have 1 at the end of the day. So we keep the frequency of B as it is, right? So we move to the next character. We have E, and then we also have E here. So we'll find the minimum frequency again. E will remain the same, which is going to be equal to 1. And we have L here, right? L also appears in this dictionary here. So we keep L the way it is, right? And we look at A. There is A also here. Wow. I don't know, Bella and Label had the same amount of words. That's really good. So we also have A here. Minimum frequency is still the same, is 1 and 1. Now, in the second iteration, right, the comparison will be between these two words now, these two dictionaries. So I'll remove this from here, and then I'll bring this back to compare. So, let's compare. Let's compare both words. So we'll have so B, is there B in this dictionary here? No, there is no B. So we'll set the frequency of B back to 0. That means we are removing B from the dictionary. So E, is there E here? Yes, there's E. What's the frequency between these two E's? It's 1 1, so we keep it the same. There is L. There's also L here, so frequency is still the same. There's an A here, but there is no A here, so we'll set the frequency of this A back to 0. Now our new dictionary here will look like this. This is our tracker, right? So our tracker will have 0 B's, 1 E, and 2 L, right? A is also 0, so we remove the frequency of A from our dictionary. So let's come back here. Now that we have the dictionary in this form, right, we want to return an array, right, that will have 2L, right, or let's say 1E, and then 2L, right, and then 2L like this. So we need to use this current tracker that we've modified to do that. Now, if you remember very well, right, yesterday I explained how we can transform what is this intersection of array 2. Yes, so by using the extend function, right, we can add the amount of time an item appeared in an array, in a particular array, into another array, right, by using the extend function. So I'll write out here, I'll write the result here. So result is going to be equal to an array, right? Now we want to add the frequency of every item into this array. We want to add how many times we've seen A, how many times we've seen, any character in the array. So we'll use the dictionary, but this time around we are going to use the dictionary in a different way, right? We are going to use both the frequency and the item itself, so that we can multiply how many times that item appears in the dictionary. So we'll say, so here's what we'll do at the end of the day. Let me come back to this place. So for every E, so this is our result array. So we'll say, so hold on. So for B, right, we'll multiply B by 0, right? B multiplied by 0 will simply be equal to 0, so we don't add 0. So E multiplied by how many times its frequency, which is 1, so we'll add E once here. and we'll have L. L appeared twice, so we'll multiply L 2 times, right? We'll multiply L 2 times to add it to this array, so it will be L1 L2 like this. So that's what we need to do in this case here. So so we need the item and the frequency. I'll say for character and the frequency, I'll say this is going to be I in, sorry, let's use, I think in, for character, does the character come before the count? Does, when you are using a key value pair arrays, I mean dictionary, let's say for character I, let me use I, or count, let's say count here, count in, so we want to use the tracker dot items, right? Dot items, there's a special items method on every dictionary in Python that will return a key value pair of every item in the dictionary. Let's quickly check that. I want to be sure that what I'm doing is correct. So I'll create a dictionary here. Let me just put pass here. Oh, come on. Pass. So I'll create a dictionary. I'll call this counter is equal to, let's say, J, and put 5 here. I know I've done this before, but I simply forgot it briefly. So let's do this again. So for I'll say I and J, or let's say count, or let's say character and count. I will not forget after today. in counter dot items, right? Print the count and the character. So let's see what this gives us. So the count is 6. Okay, so it's key, right? Sorry. Oh, so it's character, yeah, key and then value. So key value pairs. Okay, key and value. All right. So now that we know our key value pairs, I'll just remove this from here. All right. Let me see that one more time. Count is 6. Count came after character. Okay. Key value pairs. All right. So we learn every day. So we'll say results. Now we want to add the frequency of every item in the result array. So we'll say result.extend, right? Extend the character times the count. Now the reason why we use the extend function is for us to, because at the end of the day this will return an array, right? An array, and we don't want to return an array of arrays, right? We simply want to return an array of every character, not every character inside an array, right? So we'll do this. We'll say oh, so at the end of the day we'll have, let me show you how extends work, right? So we'll say we have count. I'll say I'll use word I, right? The first word, and I'll multiply. You know what? Let's say I'll call this XY, or let's say choosing variables names is just a work. So let's say if we did something like this, if we said so one way we can add items to an array is by using the append method, right? I'll call this res. This is going to be res equal to another array. So let's say we do res dot append append. No, 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 no. So res dot append will be. Let's cut this out. So character has to have, let's say, J. I'll just put J there and say res dot append character like this character, and say multiply this by 4. Right now, what you think will happen is, oh, we'll multiply 4 J 4 times into this array, right? But I'm not sure this is going to work, but let's see the output. Now you can we are not printing anything, so let's print the print print res, right? Print res. Okay, this actually worked to my surprise. I did. So this multiplied it by 4, but it's not multiplying it as a single letter, right? We have one string of four J's, right? What we need in reality is 4 strings, right? 4 strings with J's in it, right? So this will simply multiply the value, but it will insert one string. So the length of our result array here will still be equal to 1 instead of 4. We want 4 characters in the array and not one string with 4 characters in it. So here's what we need to do instead of using the append, right? We'll use the extend method, but extend what? Extend an array of 4 characters, because when we do this times 4, it will return an array of 4. So before using the extend, right, I'll use append instead, right? We'll use append instead, and when we run this, you can see we have an array of arrays, right? An array with another array inside that has 4 strings in it, right? So what we want to do instead is to use the extend function. Now extend will extract every character in this array into our main array like this. So you can see we have J here, which is what we are doing here, right? So at the end of the day, we will do this for every character in the array. If the frequency of a particular character is 0, we will not have anything in the array, right? This will be equal to an empty array. So we will not insert a particular character with a frequency equal to 0 into our result array. So at the end of the day, we'll return the result. So I'll say return results like this, results. And let's run this function to see what it is. So I'll say solution is going to be equal to the solution class, right? And print solution dot common characters. I already had the words here, right? The words are right here. I'm just going to use it. So yeah, so let's run this and see what we have. Now you can see we have 1 E and 2 L's here. So that's the solution for this question here, this find common characters question. Any questions? No questions. Hey Rosemary, how are you? Thanks for coming and joining the stream today, and thanks to everyone that is here today. I really appreciate that. So let's solve the next question. The next question would be minimum common value. Now this question is also the same as this other question here. I think, did I read this question? Wait, let me read this again. Given two integers array, given two integer arrays num1 and num2 sorted in non-decreasing order, return the minimum integer common to both arrays. If there is no common integer amongst nums1 and nums2, return -1. Note that an integer is said to be common to nums1 and nums2 if both arrays have at least one occurrence of that integer. Okay. So I mean, this is similar to the other question, right? The question we just solved now. So again, what they are trying to ask us is to find the minimum common integer between these two. Now, if both arrays had, so in this case, in this example here, we have 2 ones and 2 ones here as well, right? The minimum common integer between these two array is 2, right? The minimum common, the smallest common they have, the smallest they have in common, right, is 2. So here's what we need to do. So they have so in this case here, this will still be 2 because they have 2 here, 2 here, 3 and 3. So that's the minimum they have in common is, hold on, the smallest common to both arrays, the common to both arrays is 2. So we return 2. Is it the integer we are returning or the count of? There are 2 common integers, right, in the array 2 and okay. Wow, okay, I get it now. So we want to, even though we find the occurrence, I mean, what every integer they have in common, right? We want to still return the smallest one, right? The smallest integer they have in common. Okay, that's good. We can find what they have in common and then return the smallest amongst that, right? The smallest integer that they have in common. We are given 2 arrays. We can just do this straight away, right? By removing every item they don't have in common, right? And then finding the smallest they have in common. So this question here is similar to this, right? We can use this, count every value, right, to get what they have in common, right? Then we return the minimum between those two. Oh, where's the intersection of 2 arrays, right? You can see we have 2 arrays here. I mean, we want all possible common values, right? We can still use this. I mean, there are so many options to solving this question, right? So let's quickly solve that. So this is 2540. LEETCODE 2540. So I'm going to put it, this is an array question, so LEET 2540 LEET dash 2540 dash minimum common value, minimum common dash value, right? Okay, so let's copy. I'll probably show every method we can use to solve this question. So from the other questions we solved, right, there is now a plethora of options to use to solve this question. But anyways, let's see. We'll use the counter method, right? We can count every items and extract, into an array like this. So let's say we use the counter. I'll say count, although this is just extra step, but I'm just building up on the previous solution I provided. So this is going to be count. I'll say count. I'll call this count num1 is going to be equal to a counter, right? Let's import. So from collections import counter. I don't like the way you do from collections, because in JavaScript we do import this from that, right? Anyways, it's still good. So I'll put nums1 and I'll count the second number. Right, don't freak out. This is still going to work. So counter of num2, right? Now this is just extra step. This is just extra step because, anyways, let's just try it out. So I'll say for uh for a character in count num1, right? So let's create our result array here. We also need a result array. So results, don't worry. I know some people might be thinking, oh, why is it doing it this way? But this is a solution I provided before. I just want to prove a point that the previous solution works for this, but we just need to tweak it a little. So here we'll count every character here, right? The frequency of every character. Now remember the question says, given two arrays, right, nums1 and nums2, in sorted in non-decreasing order, return the minimum integer common to both arrays. First of all, we need to know what is common to both arrays and then return that minimum, right? If in this array 2 is common to both arrays, 2 and 2 is here, that's fine, but we want what is common to both arrays, right? What is their intersection? What's the intersection of this array here, right? We find the intersection, then we can return the minimum, right, in that list of intersection. So here's what we need to do. So we take the results. So we say if character is in count 2, right? Count num2, right? Just say result. I know you can use set to do this. It's straightforward, but I just want to show you an extra step that we made use of in this case here. But I will use another optimized version to do this. So let's say results dot extend, right? So if they have a character in common, then we add it to our result array here, right? So result dot extend. Now we okay, so here what we do before is to find the minimum between both, right? And then add the frequency of that. We don't need to find minimum anymore because we don't need wait, if we had 2, right? 2 twice here and 2 once in this second array, the minimum they have in common, what they have in common is still 2, right? Even if there is 2 2s here and 2 2s here, the minimum they still have, what they have in common is 2, right? So we don't really care about the counts rule. So if the character is in this case, if a character here is there, then we can say let's just add it straight to the, so add results. So we don't need to find the frequency, right? Result dot add append, right? If we append the character here, let's just try this out and see how it works. So result dot append, then yeah, at the end of our iteration we can just return. So we want the minimum in the result array, right? Can we use min on an array to find the minimum? Let me just do this. I'll say minimum of, let's say, can you pass it an array? Oh, you can. 1 2 0 and 4, right? Will this work? Let's print it. Print, right? Print minimum. Oh yeah, it works. So I will use I'll optimize this, but here is a brute force solution. So we can say return the minimum. um I, I don't know. This is like cheating, right? And we are against cheating. So let's write a function to find the minimum. So we'll say I'll put our current mean. Let's say our current mean, right, is going to be equal to the first character in the array. I mean that, you know what? There's no need for that. Honestly, we are still going to use the minimum. Yeah, we are still going to use the minimum built-in function. So let's do this. So results like this, right? We can return that. Let's see how this works. So solution. You know what? Let me test it out in LEETCODE straight away. This, I know it involves extra step, but hey, let's see. Let's find out what works. If it doesn't work, then we will correct it, right? So I mean, this worked. It worked just fine. Let's see. Summation, right? If the if it needs optimizing them. Oh, you see, if I did not put, yes. So my bad, my bad. There are some edge cases here that I did not even think about. Why did I do that? Why did I do? So in the case where we don't have, so we can say if return -1 if not result, which means if the result is empty, if not result, else return this minimum here, right? And what other edge cases do we look at? Say if length nums.length is going to be well, there's going to be at least one item in the array, which means we can still go ahead with this. So let's see how this works. So okay, now you can see 14%. That's not very good at all. So let's see how we can optimize this. Now, instead of it creating this, right, which adds extra space, what can we do? What's like the shortest way we can solve this, right? What's the shortest way we can solve this? Well, if we use a set, right, we can use a set and just find the intersection between those two, right, and return the minimum, right? So let's say, I mean, this will still create space in memory, but that will be less space. So say set for these two sets, right? Now the intersection between these two sets will so we return a list of their intersection. So this is going to be count num1 num1 dot intersection. Is it intersection or intersect? Let's see. Let me use this. I'll say, so I'm just trying to find out if it's intersection or intersect. I'll say this is going to be set, and let's say this is also a set, right? So we can say the intersection, we want a list of their intersection, list of what they have in common, right? List of count num1. Okay, we can use num1 or num2, num1 dot intersection. So it's intersection. Okay, we can use intersection. Oh, somebody says use 2 pointers. Yeah, we can use 2 pointers as well, but let me finish with this. What are you doing? Hey man, somebody said, why did yeah, you found the channel now. Yeah, nice to have you here. Hey, thank you, Sid. Thank you very much. All right, so let's see. Now we need to use intersection like this of num2, right? This way we don't even need to use any iteration, so we can just say yeah, let's remove this, right? So I can say return -1 if the result is empty, else return the minimum between these two. So let's run this again. Okay, so this worked, but I noticed it took a bit long for this to compute, but let's see what happens. Okay, we are getting there. This is 25%. That's another way. What's like the best way we can do this? If we use 2 pointers, right? If we use 2 pointers, will we be able? Oh my God, my time is up. Um, will we be? I mean, if we use 2 pointers, it means we. Okay, let's say um. Nah, I don't think we can use 2 pointers though. Maybe I'm not sure about how we can use 2 pointers. Because 2 pointers means uh you see the arrays non-decreasing order. Oh, wait. The arrays is sorted, right? In non-decreasing order, which means it is in increasing order. Okay, that's good. I didn't even read that very well. So if the array is sorted, right, it means every number after the current one will be larger, right? So we can use, yes, use 2.0 yeah, O of one space. Okay. Let's see. If Since this is sorted, right, it means the minimum could be at the beginning, right? It could be the first number we seen, right? What if we use, so using 2 pointers, it means are we using binary search to search, right? Are we using binary search? If we use 2 pointers, it means we are going to search within one array for a particular value in the order, right? So if that value, hey, thank you, Rosemary. If that value is not in the second array, we just skip, right? There's no need to even search for it. How about that? Code lifey. Um, you can get sorted order. Let me read this properly. You can get sorted order and see if there is two number adjacent. I'm not sure I got that. You can get sorted order and see if there's two number adjacent. I don't know. I mean, if we use 2 pointer and we use a binary search for a particular number, once we found that number, we can just return it straight away. There's no need to continue searching for other numbers, right? Until we find a particular number, because searching for because we still need to know. So let me write this out again. I hope Code Life is still here. So let's see. We have nums1 and nums2 intersection. No, minimum value here. So this is the one I'm solving down. Right. Both arrays are sorted, right? Which is a good thing for us, right? So which means we have an option to use 2 pointers and binary search, right? To search for a particular item. So let's say, for instance, we want to search for every value in nums2 inside nums1, right? Now we are not sorting, we are not adding any extra space. So let's say we are looking for 2, right? Oh my god, what's that? Binary search takes no. Binary search takes O, or it would have been O of n, but since we are searching half, right? It's going to be O of n divided by 2, which is faster than O of n, right? O of n like this. What's going on with my pen now? Oh, why is the font like that? What just happened? Oh my god, I don't like this. Anyways, let's bring back the question, right? I think we can use binary search. Binary search takes half the time to compute than O of n. So binary search takes half, right? Which is faster than O of n. So we can use binary search and then 2 pointers to quickly compute the value. And once we find a value, right? Because once we find a value, it means that's the minimum we can get, right? Because the array is already sorted. So if we are searching for, let's say, 2 inside nums1, if we find 2 inside nums1, fine, we return 2, right? But if 2 is not nums1, then it's probably going to be equal to 4. Is what they have in common is probably going to be equal to 4. So we can search for 4 as well, right? Otherwise, if we don't find anything, oh, that's still going to take O of n. But yeah, I get what you mean now. But the search is going to take half of the time. But the check is going to still take O of n. Oh, yeah. I see. I see. We still need to search for every value. But let's try it out and see. Let's try it out and see if that's going to work, right? It will hurt to try. So I'll take this. You meant to say iterate over one array and check for the, so ultimately, yes. No, it's not log n. It's going to be O of n, right? One array takes, the search is going to take half of n, right? Which is I would say O of n, half of O of n. That's what the search does. But the iteration for the check, right, is still going to take O of n. I'll probably say that's going to be O of n squared. O of n squared, yes. Instead of O of n. O log n, right? It's not O log n. It's going to be O of n squared. Binary search and iterating through every character to search for the item. Right, so let me try that out first. I'll remove this. I think it's right. I mean, this works, but it just sucks a little. So I want to provide every solution that I know of, right? And even if it doesn't work, I'll still leave it there. So what do I do now? I can commit this, right? So you know what? Let me comment this out. I'll comment this out, and I can put this as not optimized here. And the other solution would be to use sets like this. Better. So I'll put like this. So we'll have another one here. Put, okay. This is not going. I'll just say not optimized not optimized as well. So I can just put this here like this. Let me comment this out as well. So now the